Welcome to Real Civil YouTube channel. In this video, I am going to show you about the load combinations, especially service limit state of serviceability and related load combinations and how we make these load combinations. Okay, so this is what I am going to explain you, and then I will tell you how to prepare these combinations in ETABS software. So let's begin. Uh, so this is the table given in IS 456 2000. This is table number 18, which deals with values of partial safety factor for the loads. So the table is very simple. This table deals with the load combinations. So the load combinations are given here, and the factored partial safety factor values for limit state of collapse and limit state of serviceability. Okay, so in this video I am going to focus on limit state of serviceability. In the next video I am going to discuss about the limit state of collapse. Okay, so here the basic load combinations are given: dead load plus imposed load, dead load plus wind load, dead load plus imposed load plus wind load. And there is one note: if you are considering earthquake effect, then substitute earthquake load for wind load. That means if you are considering earthquake load also, then you can replace this wind load, substitute this wind load by earthquake load. So I am going to tell you how all the load combinations are getting formed, okay, and how these factors we have to consider. The limit state of serviceability, also known as unfactored load combinations. Here we basically check the deflection, story drift, top story acceleration, torsional irregularities, and many more results with these load combinations. So if you focus here, you will see the basic load cases are dead load, imposed load, wind load, and earthquake load. That means there are 4 basic load cases. Okay, so the basic load cases are dead load, live load, earthquake load, and wind load. Okay, so let's see the sub cases, or what comes under dead load, what comes under live load. So basically dead load consists of the self weight of the structure, means beam, column, slab, whatever is there, their self weight. In addition to that, superimposed a dead load. That means weight of the wall, floor finish, tiles, lift load, all these loads will be there under superimposed dead load. Then as per IS 875 part 2, we calculate the live load depending upon the occupancy. Next, earthquake load. So in earthquake load, we use different methods for analysis. One method is equivalent static method. Second method is response spectrum method, and third method is time history method. So depending upon the codal provisions, we have to perform these types of these methods of analysis. Okay, sometimes only static is sufficient, sometimes you have to perform static as well as a dynamic, that is response spectrum, and in some cases you have to perform even time history, all 3 cases. So when we perform the earthquake analysis, it is direction based. Okay, so in static analysis method there will be sub cases, and we can give the name as EQX positive, EQX negative, EQY positive, EQY negative. That means under earthquake, under static analysis, there will be 4 sub cases. Similarly, for response spectrum method, we have response spectrum in X direction, Y direction, and Z direction. So there is no negative sign because its analysis itself contains both positive and negative. That's why there is only X, Y, Z. 3 cases will be there. Again in time history X, time history Y, time history Z. Okay. So again 3 cases are there in time history, 3 cases in response spectrum, 4 cases in static analysis. And then wind load, say we are performing static wind load case, then wind load X positive, X negative, Y positive, Y negative means wind effect from positive X direction, negative X direction, positive Y direction and negative Z direction. Sorry, Y direction and X direction plus minus. So we have to substitute these cases in our basic service load combinations so that we can expand them. So basic, there are only 5 cases. Basic service load combinations or unfactored load combinations, there are only 5 cases. Dead load plus live load, dead load plus earthquake, dead load plus wind load, dead load plus 0.8 live load plus 0.8 earthquake load, dead load plus 0.8 live load plus 0.8 wind load. Okay, so I have given the meanings also here. DL means dead load, LL means live load, EQ means earthquake load, WL means wind load. Okay, so these are the 5 basic cases, but we need to expand them because we know in earthquake case there is not one case. If we perform static earthquake case, then it's EQX plus EQX negative, EQY plus EQY minus. So we have to consider the sub cases also. And if we consider the sub cases, then the final service load combinations will look like this. First, dead load plus live load, no problem. We can take it as it is. And this is unfactored because the factors maximum factor is 1 for service loads, serviceability. Second, we have seen dead load plus earthquake, but we know that there are many sub cases under earthquake, so we have to consider those cases. So dead load plus earthquake X positive. Third case will be dead load plus earthquake X negative. Fourth case, dead load plus earthquake Y positive. Fifth case, dead load plus earthquake Y negative. That means we have considered equivalent static cases, 4 cases. Suppose if you have performed response spectrum cases, then 6th case will be dead load plus response spectrum X. You can name it the way you want. 7th case, dead load plus response spectrum Y direction. 8th case, dead load plus response spectrum Z. Similarly, now we have to consider the time history cases. Dead load plus time history, dead load plus time history in Y direction, dead load plus time history in Z direction. Similarly, you have to perform for wind load. Okay, because our third case is dead load plus wind load, but we know that again for wind load there are sub cases, positive negative, positive negative. Okay, so here you can consider positive and here you can consider negative sign, no problem. Similarly, our fourth case is dead load plus 0.8 live load plus 0.8 earthquake. Now similarly you have to replace this earthquake with EQX positive, EQX negative, EQY positive, EQY negative, then response spectrum X, response spectrum Y, response spectrum Z, time history X, time history Y, time history Z. So same way I have written here 16 to, I think it is up to 25. Okay, so this portion remains same 16 to 25, only the cases related to the earthquake we are going to change. And similarly you have to perform for wind load. Okay, so these many cases are getting formed. depending upon the type of loads you are considering. If you are considering wind dynamic, then you have to consider wind dynamic cases also. Similarly, as per static cases. Okay. I hope the concept related to the service load combinations as per IS 456 are clear to you. Now from here, I am going to show you how to create these cases in our ETABS software. There are two ways. The first way is you have to create all the cases manually, or second case, you can import your Excel file. Okay, the second way is much faster, because if you are doing it manually, it will take much time, and ETAP does not provide auto load combinations related to the service load combinations. It provides auto load for design, okay, not for serviceability. So let's see. Here I have shown you, I am going to show you my load cases: dead, live, model, SIDL, EQX. All these cases are there. Only wind load cases are not there, so I am not going to create wind load case for this particular problem. But if you have wind load case, you can create the same. So first I will show you the manual way. Go to define, go to load combinations. Here there is option of add new load combination. Here you have to give the name. Always give serviceability load combinations name like this, because you have to segregate ultimate and serviceability load combinations. So this is better way. So our first is dead load plus live load, this case. So we'll give the name dead load plus live load. Keep the combination type as linear add. Here I am going to consider the SIDL, that is superimposed dead load, because we have seen here in dead load we have to consider self-fed as well as superimposed dead load. So here this first dead means self-fed. I have defined this as a self-fed, and this is superimposed dead load, that means wall load, floor finish, and all other loads are there like lift load. So superimposed dead load we have to consider, plus live load is all the scale factors are 1. Click on OK. So here you can see your load combination is first load combination is prepared. If you take your cursor, you can see the name and the factors related to the load. And this is the way you have to create all the combinations. Okay, but this is time consuming. Instead, you can do one thing. You can import the Excel. So before importing, let's check the format. How to check the format? Just go to go to tables, go to model definition, load case definition, load combinations, show tables. So here you can see our first load combination that we have defined, and this is the format. And as per this format, if you prepare your Excel sheet, then you can directly import this Excel sheet. Okay, so file. So here you can see the Excel sheet. Yes, so you can edit, you can prepare your load combinations. I have already prepared. I'll show you. Yes, I have already prepared this Excel sheet. So you can prepare this Excel sheet. Here, this is the name of load combination, that is SL1 dead load plus live load. Type linear add, auto no, load name, dead, SIDL and live, and corresponding factors are 1. Similarly, let's see 12th number case, dead load plus 0.8 live load plus 0.8 earthquake X positive. So dead, SIDL, live, EQX positive, 1, 1, 0.8, 0.8. Remaining things you can keep as it is, like linear add, no, all these things you can keep as it is. And now we can copy this and we can directly prepare all the cases. As I told you, wind load case is not there because I have not defined the wind load. This is if you have wind load case, you can consider that case also. Only thing is, whatever load cases names are there, same names needs to be appear here. Okay, so prepare accordingly. Now just copy these load combinations, Control C, go to ETAB, here go to edit, interactive database, here modal definition, load case, load combination. Okay, here click on expose all input table, click on OK. Now this is the case which we have created. First we will delete this case, click here and Control V or paste it. Now only thing is, here instead of mode, here we want to paste scale factor under this SF. So just select this column, Control X, cut, and here you have to paste it. That is, just click on apply to model. It will take some time and then you can click on done button. Now let's see the load combinations are created or not. So go to load combinations. So here you can see all the 21 load combinations are there. Even you can check here, 12th number, dead load plus 0.8 live load plus 0.8 earthquake X positive, dead is 1, SIDL is 1, live is 0.8, EQX is 0.8. So ETAB has successfully imported all the load combinations. So this is very time saving. Click on OK. I hope the concept related to the service load combination is clear, both theoretically as well as from software point of view. In next video we will discuss the ultimate load combinations. Okay, thank you. Please like, share, subscribe the channel. Thank you so much.